and it's great to be here with all of you. I was a professor for about 13 years before going into business, and so it's always great to come back to a university, meet students. And in fact, in running a company, often took the approach that it should be somewhat like a university. But it has one disadvantage. At a university, every year you get another year of students coming in who ask new questions that keep things stirred up. And so the problem is, how do you do that in a company and always keep people thinking, working on new things, etc.? Have to work at that very hard, but that so far has worked out very successfully for us. Okay, let's see if we... A little quick history, although you heard some of it. After I graduated with my PhD from MIT, or SCD actually, I stayed on as a professor there, and indeed might still be a professor there, other than we took a one-year leave for our one visit to California. And when we were there, we found we liked it very much. Came back, and just after coming back, had an invitation to go out to teach at the University of California, San Diego, which was brand new, and to help set up an engineering program. I often encourage students when I'm talking with them to be open to all kinds of changes. And here again, we, although after a couple of day decision period, decided to take that change and move to California to help set up the school. And didn't realize what a major impact actually that would have on us. In that I had published, co-authored a book on digital communications, the first such textbook, I think, and therefore was known in an area that was just beginning to grow. And so there were a lot of requests for consulting while a professor. Usually you consult perhaps a day a week. It's always a good way to keep up with what's happening out in the world. And so, but there were many more requests than I could handle on a day a week. Mentioned that to a couple of friends from UCLA on the faculty there. They said, let's start a company and share the consulting. And that's how my first company, Linkcom, started. When we first came to La Jolla, there really wasn't business. A little defense industry, but very little. And in fact, though, there was UCSD just starting up, University of California, San Diego. There was the Salk Institute in biological studies, of which I'm now the chairman, by the way, but a very good institution, also started about the same time. And Scripps Institute of Oceanography, which had been ongoing for a number of years and was kind of the basis for UCSD, and San Diego State. Well, because of starting Linkcom and beginning to grow the company, we managed to change that picture a bit. And so now if you look around San Diego, actually this picture is a little bit dated, but there are over 100 companies that kind of sprung up out of Linkcom after we sold it and left the company. And it's interesting. I find that very satisfying in the sense, again, it's sort of an education that worked very well with a whole range of people to encourage them to go out and try something new and start businesses, not all of which have been successful, but many have been. And so that's actually one of the very interesting results from Linkcom. Oh yeah, what did we do when we started the business? I mentioned start out as consulting. For probably the first 9 years or so, we did a lot of work for Defense Advanced Research Projects Agency and the government. And then, as we became known better, we're able to get a number of commercial programs. One of the interesting ones is the one on the left. We received a contract competitive contract actually, to lead a group to develop an extension of what was then called the ARPANET over to Europe, and to do so by satellite so you could get a reasonable data rate. And that required a whole new protocol. Went over to Europe, talked with some of the PTTs, the phone companies over there, that they should be interested in packet switching. And of course the reaction was, why should we be interested? And in fact, other than getting a very good lunch, did not get much interest from the PTTs. did get some government labs and some universities, and we did complete the program. And then a couple of people were working on a protocol to connect networks together, the internet protocol. And so we connected together the satellite net, the ARPANET, and a packet radio network, something like cell phones today, except much more complicated at the time. And actually, it was the very first time that there was actually messages transmitted over multiple networks using the internet protocol. And of course, none of us thought very much about that. It was interesting, but until the Computer History Museum in 2007 said, hey, this is the 30th anniversary of that, and they put together a whole celebration. So suddenly realized that indeed that was something worth remembering. At Linkabit and then later at Qualcomm, the approach to life has been to try to say, okay, what might we do something better, not just a little bit better, but significantly better, significantly different. That if we're successful, that we can find a market for it, be able to build on that, and then go on to the next product and kind of build a pipeline of products. And so there's a few of them here that I noted from Linkabit days. The upper one is the dual modem was actually initially for the Air Force. Ultimately, all the services in the US ended up using it. But it was for satellite communications. And the unique thing about it is it was the first piece of equipment, I think, anywhere that used a processor to do all of the signal processing, all of the protocol work, all of the interaction with the user, etc. And until then, the equivalent of that would have required a few racks of equipment. And one step beyond that, in order to be able to build it out of the parts that were then available, there were no CPUs available on a single chip at the time. And so we had to put together our own CPUs and did that from register chips and ALU, arithmetic logic chips, etc. How do you do that and keep the cost down and the amount of memory you need down? And we came up with, at that time, the idea of what's called a reduced instruction set computer, RISC processor, in order to minimize the number of bits that we'd have to use in the complication. And so this had 32 instructions and I think 7 registers for being able to jump among real-time programs. In any case, it worked out. We had a competition with a very large aerospace company, and we ended up winning that competition and ended up going into manufacturing on that side. Then there was another interesting program we bid on, initially with Schlumberger. They're an oil exploration company. They had the problem that a lot of holes that you're drilling, which is very expensive per day of drilling, don't work out. And so what they wanted to be able to do was send back the data from the drilling site to the customer and let the customer decide whether to go on another day or stop and move elsewhere. And so we put together a fairly rugged satellite terminal. It was the first time that the KU-band satellites were available and didn't have to be licensed for a specific location. Until then, every satellite terminal had to be specifically licensed. But we got the FCC to allow us to put them on trucks and roll them anywhere. And that project turned out to be very successful, but then we said, okay, now let's make an inexpensive terminal that can be used by business anywhere. And so we started what's called now the VSAT, Very Small Aperture Earth Terminal business. Our first customer was Walmart, and they wanted to connect together all their stores and warehouses and automate their inventory system, etc. And since we were doing it by satellite, we could also add a TV link so that Sam Walton could talk to all his employees every Friday, which he did. So that worked out very well. In fact, I haven't looked around here, but in the US, most gas stations, until the internet really moved up with fiber, et cetera, were connected for the credit card transactions with these VSATs. And then another project, Home Box Office, HBO, had a problem. They were transmitting their signals from satellite to cable head, and people with backyard dishes were taking them, competitors were using them without paying them, so they wanted to scramble their signal in an effective fashion so it couldn't be easily descrambled. And so we won that contract and built what I'll call a professional cable head descrambler, receiver and descrambler. And that was when I had my first taste of government issues, which we've never gotten away from ever since. But a group of backyard dish owners went to our Congress in the US and said, this can't go on because we've been receiving these signals. We're willing to pay something for descrambling them, but you can't just turn it off. And so we had to then develop a unit that you could use at home. So it had to be very inexpensive, very simple, reliable, and of course low cost. To do that, we had to go ahead and develop actually 3 chips to go from the professional unit to a home unit. Now this was before you could go out and buy software to design your chips. At that time, there was just a few universities, starting at Caltech, had gone to MIT, University of Washington, that were getting into computer design and testing of chips. And I had had some engineers go out the previous year to collect some of the software, take some of the courses, bring back some, and we were starting to do some what I'll call homework problems with the software because it had never really been tested, when suddenly we had to design 3 chips for this descrambler. And amazingly enough, all 3 chips worked on that first pass. And so that turned out to be a huge business. Again, you need to think about product areas, but you need to think about a whole range of other areas. In this case, where could you manufacture? Well, it turned out that if we set up our manufacturing in Puerto Rico, that at that time, any value add in Puerto Rico would not be taxed when it was sold in the US. So this turned into what I'll call simply a gold mine. About that time, we sold the company and I decided to, in 1985, to leave. They then sold this company to another one called General Instrument, who went private and public twice on the basis of that one product. So it went very well. So again, the approach was, let's think of new products. What can we do that may be new, different, ahead of time, and then be able to build a business on it? Well, we started Qualcomm July 1st, 85. As I retired for 3 months, decided that retirement wasn't very much fun. Lots of things yet to be done. And so started Qualcomm with a group of 7 others that had been with me at Linkcom. And again, when we started, we did not have any products in mind. We didn't have a business plan. We didn't have a spreadsheet of what we're going to do over the next 10 years. But we knew that digital would be of interest, that wireless would be of interest, and that we'd perhaps come up with several ideas. The first idea we came up with was on a result of a consulting contract where people were trying to use aircraft actually, a mobile satellite system, asked us to review the proposal they had made to the FCC, and would there be a better way of doing this? And the proposal was very clever, but pretty traditional. And on after the second meeting, driving back from that meeting, suddenly realized that something called code division multiple access, some of you are probably familiar, might be a better way to do that issue of providing mobile communications. Unfortunately, the FCC decided to set aside this proposal until a whole consortium to be put together, and so Hughes stopped funding us to study it. We didn't have any funding to continue, and so another project we were working on was to provide satellite communications for the trucking industry. And we built a terminal that could go on a truck that would use an existing transponder and Ku-band satellite, one for transmitting, one for receiving from the truck. This might sound straightforward, but one needed to build an antenna that could be mounted on a truck, be very inexpensive, like $50 or $60, be very reliable, and have about 19 dB of gain. And I think JPL, Jet Propulsion Laboratory, at the time had put out contracts to develop a similar antenna, but they were shooting for a $50,000 antenna with sensors on it, et cetera. And it's interesting the way these ideas sometimes pop up. I was trying to explain to our financial person why this antenna was such a difficult issue. And I stopped and thought, well, let's see, police cars have this and ambulances, a rotating beacon on top. And it occurred to me that perhaps we could have a rotating fan beam antenna and not have what's called an RF joint, but simply have a probe sticking up into the middle of a waveguide and had this rotate around. In any case, it turned out you could build the antenna for $50 and have it very reliable. There are algorithms for how to point it, et cetera. How do you keep the interference level down? And that's when we began to really use spread spectrum approach that we would then pick up again in CDMA. And so this system turned out to be very successful, other than you're always going to run into competition. Whatever idea you have, somebody else has an idea, they think their idea is better, et cetera. In the case of this system, there was another company called Geostar in the US and Lockstar in Europe that were launching satellites to provide exactly this communication. They had started with 160 million of financing in the US, and this was back again in the mid to late 80s, so it was a lot of money. And were saying they were going to eat our lunch. And so there was a competition that did go on for a while, and I mentioned to some people at lunch today that I would often get up in the middle of the night, and start thinking, are we on the right path? Is there a hole here? And then I do the calculations of our business plan versus their business plan and decided we still had the better thing. Ultimately, they did go bankrupt, and this was very successful. Actually, Qualcomm just recently sold that. It's been a great program, but other parts of the business were growing faster. It was hard to get engineering to focus enough on this, and so it was sold for $800 million. But the key aspect of it was after we had our first customer, we now began to have a cash flow coming in, and we immediately turned over to looking at the use of this CDMA, not for satellite, but for cellular system use. And so this was in roughly October of 1985. And it was an interesting time in the industry in that the first generation of cellular was based on analog, FM radio really. And then everybody was thinking, okay, we don't have enough quality, enough capacity, we have to go digital. How do we go digital? Some people looked at CDMA, but everybody gave up on it, and they were focused on either TDMA, time division, or frequency division, FDMA, multiple access, and had given up on code division, multiple access. It actually got to a point where there was a big debate in the US which way to move ahead, and there were proponents of FDMA such as Motorola and AT&T, and others that were in favor of TDMA. And in January of '89, so a couple of months after we had returned to look at CDMA, there was a vote of the industry players, and they decided to go ahead with TDMA. That was January. About March, we had enough confidence in what we were doing with CDMA to say, hey, this is really worth looking at. And so out we went to talk to the industry, but after this big fight, nobody really wanted to talk with us about it. We did get a chance to show some view graphs, not PowerPoint at the time, at a large meeting that was called, about this size actually. And I thought there might be about a 50-50 chance somebody's going to raise their hand and say, you forgot about X, this is why it won't work. But nobody did. On the other hand, just from view graphs, nobody really believed it quite either, that we had solved the problems that had stopped everybody else. Power control, handoff, the ability to handle multipath, et cetera. And so we had to build a demonstration unit. And so we did what most startups end up doing. If stay up day and night trying to get the equipment. We knew we couldn't take too long because everybody else was working on TDMA. If they got too much of a head start, it would, we would have to wait for the next generation. And so we started working in about June, and I took a chance and sent out invitations in beginning of October to people come and see our demonstration, even though it wasn't ready. And everybody did show up in early November. So this was a year after we had started to work on CDMA. And did the presentation, again, to a group, not quite this large, but almost, about CDMA. And I was getting all set to say, go out and listen and hear the system, when one of the engineers in the back of the room kind of waved and said, keep talking. There is an advantage to having been a university professor. You can always talk for another 50 minutes. And luckily, about 45 minutes later, he waved it was okay, and we sent people out and everything worked out. What had happened, we're using what was then a prototype GPS satellite system. It hadn't been turned on commercially yet, or militarily, for timing and frequency synchronization. One had come over the horizon with a problem and thrown our system off. Took a while to figure out that was the problem and fix it, and then everything worked out. So another 30 or 40 minutes and Qualcomm would not have succeeded, I'm afraid. This was the mobile telephone we used and part of the base station. Took a van to drive it around. People came in, they were very impressed with it, but how do you make that commercial? Get it into a small handset, et cetera. And so to do that, you have to make the chips. And so we then had to take a chance of making the chips. But making chips, as you know, is going to be a very expensive undertaking. And how do we finance it? So we came up with an innovative way of getting part of that funding. And that was to propose a licensing scheme to manufacturing companies that they would pay us an upfront fee that we could use for the R&D. And then should this ever be commercial, they'd pay a small royalty in the future. The first company to finally sign up was AT&T, Motorola, Nokia. A number of the companies signed up because the carriers who we went to first were putting pressure on them. Why would the carriers be interested? Well, the TDMA technology might give a factor of 3 more subscribers than the old FM, first generation. Whereas CDMA, at the time we said, might get 10 to 20, and perhaps even higher, and now actually can do about 50 times what you could have done with the old analog. And so they had an economic reason to hope that it succeeded. They put pressure on the manufacturers to sign up with us, and so we managed to get a number of licenses that gave us the funding to go ahead. It's interesting that during this period, we did succeed in going through, getting licensed, getting everything to happen, but there was like a religious war once the TDMA companies realized that CDMA should be taken more seriously. The first system was actually started here in Hong Kong, and I'll come back on that. We launched that in 1995, in the fall of 95, 7 years after we began to look at CDMA, gone through a development program, standards program, manufacturing. But even a year later, there was a front page story in the Wall Street Journal. You know, am I hyping everybody that the CDMA is really going to flop when you try to use it in large numbers? And I think there was a few people here from Stanford. There was actually 2 Stanford professors, one of whom said we were violating the laws of physics. The other said that we had fundamental technical problems we don't know how to solve. Whenever I give a talk at Stanford now, I always point out to them that CDMA has succeeded everywhere in the world except within a 10-mile radius of Stanford. Okay, so how has this moved along? Well, For the handset that we needed to have a commercial handset, we finished those chips in about 2 years. 91, we invited everybody to come back to see it with a commercial handset, commercial quality base stations. And it took 3 chips to implement the handset, the CDMA only communication part of the handset. Now, of course, we moved much further, thanks to Moore's Law. And so now, in the 3rd generation, now we're going into a 4th generation, you have a single chip on which you can have all the communication capabilities. You can have very powerful CPU capabilities. You can have the graphic drivers. You can have the camera, GPS, everything, all, as you can see, on a single chip these days due to Moore's Law. And one of the examples I love to give on the computing power, we've all heard that you carry around a lot of computing power with you. Back in 1977, Digital Equipment Corporation came out with the VAX 11780 mini computer, a great machine. Everybody loved it. We used it ourselves, several of them. Actually a year ago, in your pocket, you would carry a cell phone. You could carry a cell phone with 10,000 times the computing power of that VAX 11780. So it's just remarkable how far we've come and how far we've come with the support on changes due to Moore's Law. So we basically looked ahead and said, yes, CDMA is more complicated than TDMA, but given that we can get more and more smarts into our chips and onto the phone, then it's okay, we can handle that complication. We're not trying to do it today, we're trying to have that available next year or the year after. So that all worked out. Qualcomm, in order to then launch commercial CDMA, we had developed the phones and the base stations in order to demonstrate that the system worked and to get through a standards process. But nobody else would build handsets initially because it was too much of a gamble. And so we ended up being in the handset business as well as the infrastructure. The first commercial network was here in Hong Kong in November, roughly launched November of 1995. And why Hong Kong? Because you have about the densest amount of traffic usage, which was overwhelming the TDMA systems at the time. And they decided, okay, how do we get more capacity? We can use CDMA. For perhaps the last time this happened, we manufactured phones in San Diego and shipped them to Hong Kong. Actually, the next country to come up with CDMA was South Korea. And we had been working with South Korean companies there, Samsung, LG, and a few others, and the government, and had made the argument, and again, you know, you have technology, you have finance, you have government issues. Why should they provide support for CDMA and in fact consider it for a national standard? And at the time, they were competing very heavily with Japanese manufacturers, but they were always late. And so the only way they could compete was on price. And so the argument we used was that if CDMA does work, and this was back in 91, 92, if CDMA does work, they can get a head start and then be a major power in cellular. And in fact, that's exactly what happened. So beginning of 96, the next 2 networks after Hong Kong came up in South Korea. And again, we manufactured the phones in San Diego and shipped them out to South Korea. Then the next networks came up in the US and we were all off and running. That moved ahead until the 3rd generation, where people recognized that you needed to have not just voice, but data, and in particular internet access, but data be efficiently transmitted. And everyone in the world looked at that. All the TDMA companies finally threw up their hands and said, okay, we're going CDMA. So every every third generation phone in the world is based on CDMA. There's 3 different flavors. WCDMA, that was the GSM people went to, so they would have slightly different parameters than the US developed version or used version. And in China, they picked up on technology using TDD, and so it's TD SCDMA, but they're all CDMA basic technology. So CDMA rules the 3rd generation. 4th generation is now a switch to, sometimes you hear LTE, but to OFDMA, offset frequency division multiple access. So all these just keep moving along and providing more and more capability. We did have to make a decision which way Qualcomm would go ahead, so you end up with strategy issues. We decided that we would sell the handset and sell the infrastructure divisions, but keep the chips and software, because we said probably what we do best is come up with new technology. If you do, you can embed that in the chips, embed that in the software, and sell that to many manufacturers around the world, and therefore get that much greater acceptance. And so that's the path that Qualcomm has followed. And as far as LTE, I think we're in about 90% of the LTE phones. In general, we're in about 50%, our chips are in about 50% of all the smartphones, all the phones that are around. So that strategic decision indeed has worked off. Okay, you stand back, you look at mobile. I'm sure everybody has their favorite smartphone, but it has been growing. There's over 7 billion connections now. Many people use 3G, particularly in developing countries. It must be behind the speaker, in front of the speaker or something. Use the smartphones for their internet access, and I think that's going to, if you look at the growth curves, that's going to be more and more true. And so mobile is the place you have to be these days to be of interest, and that's going to continue to develop. And there are a lot of reasons. The computing power has gone up dramatically, all the various functions have gone up, and now more and more your phone has all types of sensors in it. And that's only going to increase as well. And I'll come back to that in the case, for example, of telemedicine. But here's, for example, the direction that Samsung has taken as far as putting in a whole set of different sensors internal to the phone. And Apple, of course, has done the same thing with the iPhone. In fact, they were probably leaders in getting some of these early sensors in. And so now if you look at the chip inside, it actually has a section of chip that's specifically designed to deal rapidly with all of the various sensors. Further, it's not just internal sensors, but we're seeing more and more external sensors. So some you might think of as wristbands, some you might think of as smart bandages, and there's more and more of these smart bandage approaches. And now with nanotechnology, you're beginning to get sensors that you swallow. So then you end up with some interesting issues. How do you communicate the short distance and do so with using very little energy, because you don't want to have any significant sized batteries, obviously. And so this whole area is going ahead, I think, and is beginning to have a major impact on our health systems, both improving quality, lowering cost. It used to be that patients would be released from a hospital, then they'd be forgotten about until a good percentage of them would come back to the hospital a couple months later because nobody was monitoring them and a problem had arisen. Now they can have the wireless monitors at home. I'll come back and talk about that. But there have been some experiments that have done, this one's from the UK, where they found that there was a significant reduction in mortality if you had people equipped with the appropriate sensors. You probably are all very aware of this fact that now we're talking about having the Internet of Things, or sometimes some people call it of everything. And that means that the communication capability is going into most of the devices with which we're familiar. All of them around the home, obviously the cars. We talk about energy efficiency, smart networks. The use is going well beyond just person to person. And probably the first of these, and people didn't quite realize at the time, was the e-book readers. There was a cellular connection in the e-book, so when you ordered a book, it actually went out over the cellular network. For Amazon, we actually hosted that at Qualcomm for the first year or two. And when they delivered the book, it would come back over the cellular network and out to your handset. So it was in a sense machine to machine, other than you were selecting which book you wanted to read. All these other things, you might see a dog up there with a little collar on it. Could have been a child, but people are more willing to spend the money on their pets. But it has obviously a GPS receiver. You can then put an electronic fence. If the pet wanders outside an area, you get an email from your pet. So all kinds of interesting possibilities. And of course, in the automobile area, which a lot of people are focusing on right now, having cars talking to each other will help, in fact, a lot of the safety issues. We're used to the entertainment aspects, but for example, now on a busy freeway, you stop and then you begin to space out again, then somebody slows down, everything stops, which cuts down the number of cars that can go. And if you have communication, you're able to know what's happening 2 or 3 or 4 cars ahead, and therefore do a much more sensible job of planning. So a whole range of new things, of course, ultimately going into autonomous driving cars. Wearables have a lot of interest now. I have my smart watch on here. It keeps vibrating ever so often. I end up looking down, so if you see me look down occasionally, you know what I'm up to. We did this kind of as a demonstration. There are a large number of companies now getting into smart watches, and that will filter itself out. This one uses a technology for display that is based on MEMS. It has little bitty mirrors that once you tell it where to go, they stay there without any further energy, so you can end up with a display that uses very little energy, full color, and video speeds. And so that's a very interesting aspect. And the whole issue here, of course, is to get the right set of applications, right set of sensors. So for example, a lot of health monitoring will be done on the phones. And then rather than having wires that Apple a long time ago popularized going up to your ears, it'll be all wireless, but still full stereo and synchronous. And so, and finally, since you do need to charge these ever so often, wireless charging, so that you just set it down on a little stand on the table, you get a night phone, a night watch or a night clock, as well as getting the charging done actually in an hour or two. Well, what other areas? And I'm only going to be able to cover a few of the things that are really going on. Augmented reality in the US, everybody watches US football. And there they paint a line to show where the scrimmage line is, where the 10-yard out line is, first down line. And it's really, of course, not there. It's virtual. And so that first popularized the use of augmented reality, augmenting actual reality. And then there have been further developments that become available as applications. So you might be in a country where some of us would not be able to read the sign, and you hold your phone up, and it translates into something you can read. And if you notice, everything in the back is scaled and fit right in. So it's as if you're looking through a window, but seeing something different. So it's augmented reality. So that obviously takes a lot of computing power to recognize the scene and set the display. If you move around with it, it'll move around like a 3D display and so on. Other uses, for example, is helping decide what you want to watch on your TV screen and augmenting it. The one I'm most excited about is the issue that whenever I meet somebody, now what's the name, where did we last meet, etc. And so having a little bit of a camera, recognize the face, whisper in the ear, and boy, that takes care of a little bit of the aging problem. So that's another direction that people are moving on rather quickly. Well, with all this use, now we're running into other issues. We're beginning to say, okay, we only have limited spectrum. We're already pushing really hard on how efficiently we're using that spectrum for any given data path, communication path. How can we really up the number of subscribers, the amount of data? And of course, one of the major growth areas is video on demand. Everybody wants to be able to see some screen that's unique to them perhaps. They want to upload and then perhaps download them. And so one is now working very hard on how do you get this further increase. And part of that is now being referred, although it's something not well defined at this point, as fifth generation, getting more bandwidth but also using the available bandwidth much more efficiently. Part of that answer is going to very small cells that you'll either have in-house or outside. Right now they're Wi-Fi, but they'll become cellular with handoff capabilities, data capabilities, etc., that will allow you to have kind of a uniform experience as you go in and out. In fact, some of that energy will leak outside of your apartment or outside of your house or outside of your office, and if you permit, it could be used by people driving by and augment the macro network. And so a number of these directions are going, as well as new areas, one of which we refer to as LTE-B or LTE broadcast, where you deliver the same packet to multiple phones. So if everybody's watching the same sporting event or news event, you're not having to give each one an individual stream. They can share the streams. More and more now also peer-to-peer, we call LTE Direct, where your phone recognizes another phone is nearby. If you want to talk to that person, you don't go through a base station, you just go directly to that phone. So that's being demonstrated now. There's some spectrum available which you can only use for transmitting in one direction, usually the downlink to the mobiles, and use that to augment the amount of TV that can be carried. And finally, there's new spectrum at very high frequencies which doesn't propagate through walls very well, but still has huge bandwidth. And so beginning to use that to get very high data rates in areas where it's usable, given that you can hand off if you get to a point where you lose that signal. And so we just demonstrated LTE, an unlicensed band where you can share the band with Wi-Fi but do it more efficiently, and also going to very high data rate type capabilities. Whoops, I think I had it on there actually. Yeah, new frequency, so Y-gig, we just demonstrated a 7 gigabit per second, actually on 6 gigahertz spectrum. And so the CPUs, the chips, actually will take care of that data rate, and this new modulation, the higher frequency and bandwidth, will give you these very high data rates. So things are still progressing ahead very rapidly. Okay, how do we make good social use of a lot of this technology? And again, a lot of these uses have been discussed. We had set up a number of projects, continued to add to them in a variety of countries, where we look for local partners to work with so that we can demonstrate different capabilities. One in your occupation, how do you support that? Well, we've done some work for fishermen, for farmers, etc. For fishermen, obviously you want to know weather conditions. You also want to know where the fish are biting. But most importantly, you want to know which port to go back to and which market to sell your fish, because where do you get the highest price? And so this will enable the fishermen to go ahead and eliminate to a significant extent the middleman and be able to get some significant more earnings. And so that's worked out really well. It's now become a fully commercial service in a number of different countries. Healthcare, again, I mentioned that earlier, but telemedicine is going to be a more and more major, have more and more major impact on everyone's health. And clearly with the Ebola breakouts, that's a critical aspect. But the ability to go ahead, have clinics that are not staffed by trained people or occasionally staffed by doctors, but not with a large amount of equipment, being able to send data back to a hospital, get diagnostic work and recommendations and send that back. And so we've been setting up a number of these clinics in a variety of different countries, and that's been working out rather well. Similarly, the phones have very good cameras on them now. Somebody has a skin problem, you can take a picture, transmit that to a place where there is a dermatologist, have them come back with a recommendation, what ointment or how best to go ahead and treat that, or whether it perhaps is a more serious problem. So that's been moving ahead rather nicely. Diabetes has been a growing problem around the world, and the question is, how might one be able to detect that and recommend treatments and monitor those treatments? And we have a program going on actually in the city neighboring San Diego, Tijuana, on that kind of effort. One that I'm very interested in is just seeing more and more use of technology in education. And we've been talking about that probably for 30 years without very much happening. And I think this decade it finally is happening in a variety of different ways. We've got involved back in 2000. I was with President Clinton on a project to show the problems with the digital divide, that is inadequate access to the internet in many communities. So we're at a relatively poor village in North Carolina, village I guess really, in North Carolina. And we set up what was then a demonstration 3G system with high data rates at a small manufacturing plant to then allow and show how he could have great advantages in being able to reach customers, and be able to reach suppliers, and being able to market the materials, and be able to maintain. Actually, President Clinton got so interested in hitting the keyboard and watching what happened on the screen that it took an extra half an hour to pull him away and him to a roundtable discussion, but that was interesting. Governor Hunt was there, was governor at that time, and he said, okay, it's one thing to show a demonstration, an experimental system. When it's commercial, will you come back and do something really useful? And so we did come back and gave about 6 years ago, smartphones to students in 4 different high schools around North Carolina. We gave some additional material on, of course, how to use the phones for the teachers, got some additional curriculum material, etc. And off they went. At the end of the first year, we went back to see, well, of course we had been interactive, but went back specifically to see how the students had fared. And we were amazed that, as you note here, there was one teacher in one of the high schools that had a class with phones and a class without phones. Class with the phones, 100% of the kids passed their state algebra. One without the phones, only 2/3 passed. And what's happening? Why is that huge difference occurring? And so in talking with the students and the teachers, it turned out that having access to the internet 24/7 was key, and it was largely peer-to-peer education. Student would go home, try to do a homework problem, get stuck, parent can't help, usually have to wait till the next day to go to school and find out what he's missing or she's missing. Now could go online, talk with other students, get help. Also, a student that came up with a really clever way of doing something would video it and send it around to the other students. So there was a lot of peer-to-peer education going on, and that turned out to be really very, very effective. And so that program now is growing quite a bit. The most recent one, I understand, is a lot of ultrasound work being done here in bioengineering. But this was a project we set up in Morocco where have mobile ultrasound devices connected to phones so that one could send the data back to a remote location and be able to therefore monitor many more pregnant women. That was the focus of this, in short time and at low cost, as you can see. And that apparently has had a very significant impact, including encouraging more of the women to go to places where when they have the baby, they can indeed get a better treatment. So the whole wireless, just focusing on a variety of these areas, is having a very large payoff. We're just really getting into it. So thank you all very much. And
the first phone I got when I came to Hong Kong in 1996 is a Samsung CDMA phone. So I didn't realize it from you, okay? But I'm truly impressed by the end of the talk when, after, making using technology, making all this fortune, Dr. J comes to pour it back to society and not just to the US, to the whole world. This is truly the spirit of our school want to do the same thing, do well, do good, and this is a perfect example of that. I'm sure you have a lot of questions. May I take the first question? Yes.
So you have a lot of successful moments in your life, but I wonder, how can you overcome the difficulties in your life you have seen? And can you give us, the young generation, any suggestions how to be successful like you?
I want to know.
first of all, get a very good education. When I decided to leave academia and go into business, one of my rationalizations at that time was that I had been teaching theory all those years, and of course everybody's skeptical about what's the value of all this theoretical stuff. And so going into business was one way to demonstrate that. Secondly, obviously, one needs to gather very good people to work with, and then give them a very good working environment, encouragement, always trying to think of new ways of doing things. I also mentioned at lunch that I often think of business as being something like the university, and particularly graduate education, where often the student will come in, you talk with them a bit, might give them an idea on which way to proceed or some suggestions on work they've been doing, and off they go. Well, in a business, you do the same thing, except there your end product is something you can sell, and not just a thesis, not a thesis, I shouldn't say just. And so there's that aspect of it. So find very good people, find a very good working environment, and then find interesting things to work on, because good people always like to work on interesting things and things that are not just a little bit better, but kind of open up a whole new area. And to find those, you have to be opportunistic. You can't write a strategic plan and stay on that, because unexpected things can be expected. And so you always have to be open to thoughts, new ideas, problems that people may be coming up with, and occasionally those will ring a bell and say, hey, maybe we can do this and solve the problem. So you have to be very open, very opportunistic, and of course, work hard.
This is George from SHTM. I'm very glad to see Cornell alumnus here. I got my PhD from the Cornell Hotel School. Can you tell us something about the future use of the wireless in the hospitality and tourism field?
First of all, I will note that both my wife and I graduated Cornell, so we're both Cornellians. We met there sophomore year, married after her graduation, and someone mentioned we just celebrated 60 years, so it's been a little while since. Although we get back to Cornell quite frequently. But my high school... Now we have had 2 grandchildren. Thank you. Who've gone to, one's still there, going to Cornell. I might mention also, again with the idea of change, when I graduated high school in New Bedford, Massachusetts, a small city, my high school counselor said there was no future in science nor engineering. And no one in the family had a background in higher education, could dispute that. The folks owned a small restaurant at the time. The counselor said, oh, you should go to Cornell to the hotel school. So I was in the hotel school for a year and a half, and there were some valuable aspects to that, besides meeting my future wife, that I had a year of accounting, and that has been very, very useful over the years, as well as some business law, some other things that have turned out to be very handy. Where's it going with the hotel industry? And well, I think now, at the fairly simple level, you go into some restaurants, and whereas you might